Okay, so our next example is area of a triangle is 120 meters squared. Height is 24 meters. Find the length of the base. So this requires us knowing the area of a triangle, right? So let me write that down. Area is equal to 1/2 base times height of a triangle. So we know that area is 120 meters squared and that the height is 24 meters. So what we need to do is plug these values in and then look for what the base is. So kind of what we've been doing so far. So 120 equals, and I'm going to omit the units and we can add that back later. So half of base, whatever that may be, times 24. Keeping in mind that multiplication is commutative, so we can change the orders of these. So 120 is equal to half of 24, which is 12 times b. And finally, we could divide by 12. So 10 is equal to our base, and you can check it, right? 1/2 10 times 24 is, in fact, 120. So we know that we did that one correctly. So that's it for that question. Next one is what we have here. So this one is a kind of a geometry extension. So let's review a few things. So this part is saying 8x minus 8 degrees. And then this part is 6x plus 2 degrees. And whenever you have two lines intersecting, we know that the angles that are kind of facing each other, or opposite of each other, I guess, are the same. So we can say that 6x plus 2 is equal to 8x minus 8, and now solve for x. And then once we know that, we can find out what the degree is. So let's see, whichever way you want, but I'm going to subtract 6 first, or 6x. And so that gives me 2 equals 2x minus 8. And I'm going to add 8 to both sides to isolate 2x. So 2x equals 10. Finally, I'm going to divide by 2. So you divide each side by 2, I get x equals 5. But that's not the answer, right? The answer is what the degree is. So while I'm checking, I'm going to find out what the degree is. So 6x, which is 5, plus 2. So that's 30 plus 2, so it's 32. And to make sure that it was right, I'm going to do it with the other side. So 8 times x, which is 5, minus 8. So that's 40 minus 8, which is 32. So I know that I found it right. Let's do another one. So we're reviewing the terminology that we had before. So this one, although it's not explicitly stated, you can draw it out. That's supplementary, right? So they add up to 180 degrees. So we can do x plus 11, which is the first angle, plus 6x plus 29 must equal 180 degrees. And for this question, the problem was asking what are the degrees, the given degrees. So we have to find out what x plus 11 is, and we have to find out what 6x plus 29 is. So keep that in mind that after we solve it, we have to plug it back in. So commutative property states that we can switch orders. So x plus 6x is 7x, and then 11 plus 29 equals 40, and that equals 180 degrees. So now it should be pretty easy for you to solve once it's set up. So you subtract 40 from both sides because it's itself and it's additive inverse, so it goes to 0. So we have 7x equals 140. And then divide by 7 on both sides, we get x equals 20. Keep in mind that that's not the solution for our problem. It's a solution for this set of equation that the equation that we made, but we were being asked what are the degrees. So plug it back in. 20 plus 11. So we get one angle is 31 degrees, and then the other one, we're going to plug it in. So 20 plus 29. So let's see, 120 plus 29, which is 149. And then we can check that these two angles are actually supplementary. So 31 plus 149 gives us 180. So we did that one correctly. So now we're going to jump into different types of questions. So after this part, so let me just differentiate that. Now we can solve things for different variables instead of explicitly solving, like having one variable and then other numbers in there, but the process is exactly the same. So if we have area equals length times width, and we want to solve for W, so if I write it explicitly, it's saying area equals length times the width, right? So just like when we have, say, A equals 2W, and if we want to solve for W, we would divide by 2, right? Same thing here. We would divide by L on both sides, and here we are assuming that L is not equal to 0, right? Because if it was, it would be an undefined. So area divided by the length would give you the width. And we're done here because it's solved for W, and that's what we were being asked for. Similarly, let's do another one. So here's our perimeter formula. P equals twice the length plus twice the width, and we want to solve for L. So that's what we want to solve for. So we notice that this part we don't want in there, right? So we do the opposite operation. So we subtract out 2W from both sides. And keep in mind that these are not like terms, so you just write it out as is. And then 2W minus 2W is going to be 0 regardless of what W is. So we're just going to have 2L left. And finally, you divide by L. Oh, sorry, divide by 2. And you get L is equal to perimeter minus twice the width divided by 2 will give you the length. Okay, so we're manipulating the equation similar to how we do with numbers, only now we have different variables that we're trying to solve for. So last one. This is the area for the trapezoid, right? 1/2 height B plus the big B, and we want to solve it for H. Okay, so a little bit different than before. So the first thing we want to do is I'm going to multiply the entire thing by 2 because that's a multiplicative inverse of 1/2, right? So I'm going to have twice of A is equal to, now that's going to cancel out with this one. So height base plus big base. And now the operation here between H and this part is multiplication. So to get rid of that, we're going to divide by what's in the parentheses. Right? So overall, H, because this will go to 1, equals 2AB plus big B. Okay? And that is the end of this section. And check out the next video for the following section. Thank you.